shit.
That's what I'm talking about.
Wait.
Okay, now, from the beginning.
Okay, so my name is Bojan Skaljak. I'm a senior developer, technologies engineer from Nvidia, and I will be talking a little bit about how you can improve your applications using VRWorks and Ansel plugins. So here's the quick talk overview. We're going to discuss a little bit the VR rendering challenges, and then we're going to focus on solutions provided by the VRWorks graphics features. So we're going to cover multi-resolution shading, lens match shading, single-pass stereo, and VR SLI. And then we're going to have a look at the actual plugin itself in Unity. And then after that, the Ansel plugin and the highlights plugin. So Shavin already covered that, so that's from the old presentation. Okay, so what are the VR rendering challenges, right? So VR is obviously different than standard rendering because there's two eyes we need to render for, so there's left and right eye. So obviously the first challenge is that we don't want to process geometry twice, we just want to render the scene once as it is, ideally. And the second challenge comes from the actual lens distortion, right, which is basically how the HMDs work, right? So once you look at the VR image, because of the lens, shape of the lens, there's a lot of pixels that actually get wasted. And simple reason is because the GPUs are capable of rendering a simple rectangular images, and that's not really what you want when you are rendering something that you're going to map onto the lens. So if you have a look here on your right, what's marked there in the red color is basically all the pixels that actually get rendered by the GPU, but at the end they get wasted because you never get to see them once you're looking at the image through the HMD. So these are the two challenges. How do we render both eyes in a single pass, and how do we reduce a pixel waste caused by the lens distortion? And now I'm going to show you how VRWorks can help with that. So this is traditional stereo rendering, right? So it requires two geometry passes. Obviously, that's not good. You need to call the scene for the left eye, call the scene for the right eye. Traditionally, the CPU does the calling twice, and then you have to render everything twice, and it's really bad. So on the CPU side, you can fix these things by using a single frustum a little bit wider, and then you call the scene only once. But on the GPU side, you still have a problem that geometry gets processed twice. Now, some engines use instancing, which means that you issue a single draw call, but to render two items at the same time. But the problem is that only saves you a CPU time. The GPU still has to process both instances. All the attributes have to be loaded. Everything has to be done twice. Go through all the vertex shader, all the rasterizer states, and everything. And obviously, pixel shader has to run twice. So the instancing, the standard instancing, really doesn't help much with the VR, unless obviously it saves a little bit of a CPU time. So how can VRWorks help with this? One really cool feature that comes with the VRWorks is called single pass stereo. Unfortunately, the naming of this a little bit strange because it's almost matching the name of the Unity's single pass stereo, which is not the same thing. So what it means in Unity is basically what I just described. It's basically instancing, rendering. But in our case, starting with a Pascal architecture, we actually have the ability to render geometry only once, process geometry only once, and display it for both eyes. So this is the hardware acceleration that's coming, that's available on the Pascal and the future architectures. So that's the single pass stereo that allows you to significantly reduce processing time, especially if you have a lot of complex geometry in your scene. So not needing to load all the vertex attributes on millions of vertices in your scene actually can help significantly if you have really complex geometry. So if the geometry is your bottleneck, this is actually a feature that can greatly improve performance in a VR. The other feature which also can address the problem of processing geometry only once is obviously the VR SLI, right? So in VR we have two eyes, so it's kind of like a logical that you want to have two GPUs, right? So if you have a system where you have two GPUs, then you can dedicate rendering for each eye on a specific GPU. Now, this is basically how the standard SLI works. Like this has been around for a long, long time. So, you know, CPU would process frames, and then the GPU 0, for instance, will take frame n, and in the parallel, GPU 1 will do the next frame, and then they get presented on a display, right? But this, as you can see, this adds latency, right? This can help with the frame rate, but it's actually adding latency, and that's pretty bad, as we all know. Latency in VR is actually not a good thing to have, right? So with the VR SLI, we are taking a different approach, right? So CPU still does the same thing, right? It has to create frame n and frame n plus 1, but now the GPU 0 takes over the left eye, and the GPU 1 takes over the right eye. So now we get to process left and right eye at the same time on 2 different GPUs, and then we are significantly reducing latency, and we are solving a problem of geometry being processed only once per GPU. So this is basically how VR SLI works and how we can save performance, obviously, improve the performance in cases when you are geometry bottleneck. Actually, in VR SLI, even if you are pixel bound or geometry bound, because you have actually 2 GPUs, it helps. It's almost like an ideal scenario for VR rendering. Okay, so these 2 approaches that I just described, they help with reducing the geometry load. Right now we're going to see how there are 2 additional features in VRWorks that can help you reduce the pixel load, right? So as we discussed, you know, GPUs render rectangular images, but HMDs really want something that's distorted, that's actually matching the lens better, as you can see on the right. So all these pixels in the black there, they end up being wasted, right, on the right side. So if you take a closer look at the certain regions on your screen, right? So when you render something, the central area, which is here marked, the central area more or less stays the same once it gets projected onto your on the HMD, right? Once it gets projected on the lens, there's not much difference in terms of pixel density and resolution in the central area, which is this green circle here. But if you pay attention to this area on the edge on the left, which is marked with the red rectangle, once that gets distorted there, normally in a post-processing effect, before it gets presented to you on an HMD, you can see that this area first is skewed and it's significantly smaller. So you see that you are basically over-rendering in this area, right? Everywhere around the edges, because that is your peripheral vision, everything around the edges, which is peripheral vision, you are basically over-rendering. Because if you look at your arm in front of you, you can actually see a high detail, all the details of your skin and everything. But if this arm is actually here, you can still see, oh yeah, I see an arm over there, but you cannot actually recognize any detail. It's in the peripheral vision. So that's the idea of how we can help in this case is based on all that, right? So the idea is actually really simple. We decide to split the viewport. Instead of having a single viewport, we can have multiple viewports. In this case, the easier solution is obviously to split it in a 3x3 grid, so you end up with 9 viewports. So then what happens is that we keep the central viewport at the maximum pixel density, so that means nothing changes in the central viewport, but we can tweak the pixel density in the edges, right? All these 8 viewports around the edges, we can change the pixel density, and it's fully controllable by the developers, so they can set it to whatever they want, really. And they can go as aggressive as they feel like it fits their game. And so what happens at the end, you can see that all this, where it says not rendered, all this black area in the rectangle on the right actually never gets rendered. So you are saving a significant amount of pixels. And if your game is obviously pixel bound, this is the right way to go to address that problem. So how does this work? This is an actual hardware feature which was first available in Nvidia Maxwell architecture, and obviously it's available in Pascal and all the future architectures. And it's basically based on a so-called fast geometry shader pipeline. What that means is that we have a special custom version of the geometry shader which is capable of broadcasting geometry to multiple viewports at the same time with basically very little or no overhead. So that's why this really works really well in practice, because obviously there's 9 viewports. You don't want to render everything 9 times. So we are broadcasting triangles automatically to all 9 viewports without really any overhead. So this is achieved with the hardware accelerated geometry shaders. So I have some performance data here. Now, one interesting thing about the VRWorks, the name is a bit unfortunate, because the VR implies that it's only useful for the VR, but actually it isn't. If you think about this, multi-resolution actually works in desktop as well. So if you're playing a first-person shooter or maybe a racing game and your user is running a 4K monitor, it's probably highly unlikely that they're going to notice a different pixel density around the edges on the screen, right? Because if you're in 4K, you don't necessarily have to render 100% of your frame in full pixel density. So this is actually an example of desktop title distance, which we applied multi-resolution shading on obviously Windows 10, and it was 1080p resolution, and we basically saw 20 to 54% performance increase, obviously, if you are a pixel. Now, this is very important. You have to be pixel bound. If you're not pixel bound, then this feature really not going to help you. But what it does for you is it allows you to add extra post-processing effects and create heavier shaders, and then reduce the amount of pixels you have to process, and you can have a nicer looking game while only processing the pixels that you really need, right? This is really neat feature. And you can see that the scaling is pretty well from like default rendering, conservative and aggressive, and that's basically what that means is you can tweak the viewport sizes, is fully programmable, and then you can go very aggressive and make this central area really tiny, or you can obviously be conservative and you know, maybe reduce only like 5% on the edges or something like that. So this works actually in desktop and in a VR. So the other feature which is trying to achieve a similar thing as multi-resolution shading is the lens match shading. So this feature is Pascal only, similar to the single pass stereo, which is almost Pascal only. So this is not available on Maxwell. But the MRS, the multi-resolution, is the only feature that's actually available on older hardware on Maxwell. So lens match shading is basically using a very neat trick, which is also hardware accelerated, where we are distorting the projection plane. So your camera projection plane, which is normally flat and facing the camera, gets distorted in homogeneous space, and this is fully hardware accelerated. So the image that we produce looks like once the plane is distorted and then gets projected on the screen, you actually get the image on the right. Now, what's interesting about this image on the right is that it is actually pretty close matching what the lens expects in order for actually to map it correctly. And again, all the area around, which is black, never gets rendered. So instead of rendering a fully rectangular image, which you see on the left, with the lens match shading, which is hardware accelerated, you can actually get an image on the right, which is much better fitting lens, and it can be literally applied directly onto the HMD. So the VRWorks is actually available in Unity as a plugin. We actually released it last year at the GDC, so it was 2017.1 or higher. The version of Unity is required. It's available on the Asset Store. You can download it. It supports multi-resolution shading, single-pass stereo, lens match shading, and a VR SLI. It's at the moment it's only DirectX 11. Supports basic post-processing and only forward rendering. Now, again, my experience is that most of the people don't really use geometry shaders in their games because they are pretty slow most of the time. But if you are using VRWorks, then it gets a bit more complicated because we need to use a geometry shader pipeline to do all these tricks and broadcast the geometry. So with the default implementation, you can't really use geometry shaders in your game. But I mean, in a complex case, there is a way to work around it, but it requires manual tweaking and stuff. Yeah, so some main points. It really comes as a native plugin, so it's some DLL. You download it from the Asset Store, and everything is automatically set up in your project. You just have to attach two C# scripts to your camera, and then basically just, it's very, very easy to set up. Just ask, is feature available, and then you activate the feature, right? Whether it's a single pass stereo, lens match shading, multi-resolution, and so forth. Now, but it's really important, again, I'm gonna repeat again, that this only helps if you have a GPU bottleneck. And I've received a lot of questions from people, well, I integrated VRWorks and it doesn't do anything for me. Well, it's because you are CPU bottlenecked or your scene is way too simple, so the GPU is too powerful, it just renders it too fast anyway. So if adding this feature only really helps if you have a GPU bottleneck. And again, it also allows you, if you don't have a GPU bottleneck, you can actually create one by making your geometry more complex, by adding more post-processing, by making your shaders more complicated, and then you're going to create a richer content, which is going to start to run slower, your VR experience. Then you apply these features, and then you get a much better user experience with the better-looking content, right? So that's the common misconception that, oh, I just enable VRWorks and it's magic, right? So it serves the purpose, but you actually have to have a GPU bottleneck. A quick note on the image effects, right? Because we are actually here working in nonlinear space, especially with the multi-resolution shading and lens match shading. You can't just take post-processing or image effects as they are and just apply them, right? There's some tweaks need to be done in order for this to work. And the reason why is because if you remember with LMS and MRS, you change the pixel density, and this will affect the density of your depth buffer. So any of the post-processing effects that are sensitive to depth, big gaps in the depth between neighboring pixels might have a problem with this. Again, in VR, most of these artifacts will happen in a edges, right, in the peripheral vision, where most of the people and most of the time, in my experience, it's very hard, almost impossible to notice any of them. Obviously, if you apply this in a desktop case, like in a 4K game, in a standard title, then it'll be obviously more noticeable around the edges if there's a transition. But there are ways to fix and address these things, and we have a couple of samples which we uploaded on the asset store where you can download and have a look at how we modify the shaders to get the basic stuff, screen space ambient occlusion, depth of field, and stuff like that, how to get it to work with the features. And yeah, so here's just a quick example of how this is done in a screen space ambient occlusion, right? So when this is a standard screen space ambient occlusion shader where we are sampling camera depth normal, and then the screen space ambient occlusion and combining to produce the results, right? So with the VRWorks, stays more or less the same, except that you have to use the specific functions provided by the VRWorks. They are all inside of the VRWorks.cg Inc. And these are helper functions that allow you to actually convert your shaders so they work with the VRWorks correctly, but if the VRWorks is not on, they will just revert back to the default implementation. So it'll just work regardless of which path you're using. And of course, if you're running on a hardware that doesn't support VRWorks, then it also defaults back to standard implementation. So this is just one example. Like I said, you can download it from the asset store. There's an Nvidia VR sample, and also there's an Nvidia version of the Viking Village Unity's demo, which we modified to use. It's a desktop multi-resolution example. Okay, so that's about everything I have on VRWorks, and I have just a couple of slides on Ansel plugin. Ansel plugin is also available already on the on the asset store. It's a very cool tool. It's similar to the Nvidia highlights, except this is not working based on the events, right? So there's no triggers based on the events, which is in game like you killed an opponent, whatever. This is fully controlled by user. So the way this works is that you integrate your plugin in your game, and then if the user is running on a capable driver, they can just press Alt F2 and they can freeze the game and take over the control. So this is really cool because then you can actually move your camera however you want. I mean, obviously developers can put restraints and restrictions on where you can go, but the idea is to let people change set up some really cool shots and move some away from the regular path where the character goes, and and just explore the world in a different way. And of course, then, because it's a free camera, you can take screenshots, really high resolution screenshots. I believe it's 8K. It all depends on how much memory you have, really. And you can apply all kinds of cool filters. You can even capture it in an EXR format, then you can later edit in Photoshop and professional tools. I already mentioned super resolution, so you can go to like 8K, right? It just tiles. It takes a couple of seconds to capture like a really, really high quality images, and also has a 360 capture. So Ansel is, like I said, it's a Unity plugin. It's available in Unity 5.6 or higher. So again, it's implemented as a native plugin. It comes with one C# script that you need to attach to your camera, and it's even easier to use than VRWorks, because there's no need to modify any shaders or anything. You just basically detect. The plugin basically allows you to communicate with the driver and detect whether the Ansel is available, and then just after that, users can press Alt F2 at any point and take over the control and capture cool, screenshots and stuff. And yeah, that's about it. So if you have any questions, we're happy to answer. Yeah, thank you.
On the VRWorks side, within the... It was... Oh, sorry. There, now it is perfect. For the VRWorks implementation with the physics engine, does it end up causing any other kind of, like, I mean, you're talking about specifically the bottleneck, like, needed to be on the GPU side. Is there any extra benefits that come with using the VRWorks portion with the physics engine as well on that end?
Absolutely, yeah, because anything that's alleviating any work from the GPU, in this case, right, it lets you actually run physics on it. And actually, good example, that's a very good question, and a good example is the Nvidia's VRWorks, which we released, right, which is fully utilizing Nvidia physics, everything's running on GPU, and the VRWorks actually helps by reducing the pixel load and the geometry load, that we can actually free these extra 20–30% on the GPU. We can run extra physics, which means you can throw more particles, or you can do more fancier physics because you have these extra 20–30%. Right? It can be significant help. Any other questions? Okay, well, thank you very much. Until after then.